In this example, I need to find the following information given here, and then I need to sketch the graph of f of x equals the quantity x plus 3 all squared minus 4. Well, what type of function is this? Notice if I square this binomial, the highest exponent on any x is going to be a 2. So this is a quadratic function, and this quadratic function is given in standard form. So I need to compare it to y equals a times the quantity x minus h all squared plus k. If I graph this function, I'm going to get a parabola whose vertex is at hk, and if a is positive, the parabola will open up, and if a is negative, the parabola will open down. So looking at part A, does the parabola open up or down? Well, that depends on the value of A. And what value of A do we have in our example? Remember, we're too efficient to write it, but A is equal to 1 in this case. And 1 is greater than 0. Therefore, this parabola is going to open up. Next, I need to find the vertex. Remember, the x value of the vertex, h, is the opposite in sign to the quantity that's inside the parentheses. The y value of the vertex is the same sign as this quantity. So looking at our example, the x value of the vertex is going to be the opposite of this number. So the x value is going to be negative 3. The y value is going to be the same sign as this, so it's going to be negative 4. So the vertex is at negative 3, negative 4. I can double check that with my knowledge of transformations. If I have a plus 3 inside the function, that is going to shift the graph left 3 units. And a minus 4 outside the function is going to shift it down 4 units. Next, I need to find the axis of symmetry. This is a vertical line that goes through the vertex. Equations of vertical lines have the form of x equals a constant, and since this line goes through the vertex, it has to be x equals negative 3. Next, I need to find the y-intercept. You do that by setting x equal to 0 in the equation of the function. So f of 0 is going to equal x plus 3, so that's 0 plus 3, all squared minus 4. 0 plus 3 is just 3, so that's 3 squared minus 4. 3 squared is 9, so 9 minus 4 equals 5. So the coordinates of the y-intercept are 0, 5. Next, the x-intercepts you find by setting y equal to 0, or in this case, f of x equal to 0. So you get 0 equals x plus 3 all squared minus 4. Now, there are several different ways of solving this quadratic equation. I think the simplest is to use the square root method. So the first thing I'm going to do is isolate the x plus 3 all squared by adding 4 to both sides. So I get 4 equals x plus 3 all squared. Now I'm going to take square roots of both sides. So I'm going to get plus or minus the square root of 4 equals the square root of x plus 3 all squared. So I'm going to get, when I square root this square, I'm going to get x plus 3 equals plus or minus the square root of 4 is 2. So it's plus or minus 2. Subtract 3 from both sides, x equals negative 3 plus or minus 2. So now I need to break it up into its two solutions. x equals -3 plus 2, and x equals -3 minus 2. So x equals -3 plus 2 is -1, and -3 minus 2, the second one, I get x equals -5. Now be careful, these are two separate solutions. Some students try and put these together as one answer. But remember, we know the y value is 0, so my two x-intercepts are at -1, 0 and at -5, 0. So now I'm running out of room. I'm going to go on to the next slide. Now I need to sketch the graph of my function. Here's the information I found from the previous slide. So the vertex was at -3, -4. So left 3 and down 4. So there is my vertex. The axis of symmetry is a vertical line through the vertex. So I'm going to graph that in with a dotted line. There's my axis of symmetry, x equals -3. The y-intercept was 0, 5, so start at the origin, go nowhere in the x direction, up 5 in the y direction. X-intercepts are -1, 0, so -1, 0 is here, and -5, 0 is right here. Does that look like a parabola that's going to open up? Yes, it does. And often you're asked to graph 5 separate points, so I need to just find one more point on my parabola. And using the axis of symmetry, I think I should have a point that is 3 units to the left of the axis of symmetry at y equals 5. So let's double check that. Let's find the value of the function at -6. So plug -6 in here. It's -6 plus 3 all squared minus 4. -6 plus 3 is -3 all squared minus 4. -3 all squared is +9. 9 minus 4 equals 5. So that obeys the symmetry of the function. So my fifth point is at -6, +5. And now all I have to do is graph a parabola through those points that opens up. I'm going to put the video on pause for a second. So here is my parabola. It doesn't look very pretty, but as long as you go through all the points and you make sure that the graph does not go below the vertex, it'll be fine. And the last thing we have to do is find the domain and the range of this function. Well, the domain of every quadratic function will always be all real numbers, otherwise known in interval notation as -infinity to +infinity, but the range will not be all real numbers. So if I look at my graph here, if I come up from -infinity, what is the first y value I hit on my function? It's at the vertex. So the first y value I hit is -4. There's a point at -4, so I use square brackets. And now my graph goes all the way up to +infinity. So the range is square bracket -4 to +infinity.